My name is Thanit Keatkaew, PhD student. I'm glad to be here to present the review paper and my progress. For my progress and research domain is consists with application research of parallel optimization technology in hydrological models. For CE and coursework, I passed already, and to semester I prepare for proposals examination. Okay, for the preview paper is name a comparative review of a contour and raster-based method for prediction of surface water flow from them data. The author are อาจารย์อาจารย์วิทย์ชันทวิโรจน์ and ธัญวัฒน์ลิ้มปิติ and Andrew Sega from Queensland, Australia. Before we talk about in detail this paper, let me show you some video. As you can see, this video shows about water flow of our planet. As you can see, for example, the question is why we need to draw surface water flow like this. Okay. On this figure, you can see the delineate basin of stream 1 and stream 2 and flow from the turbidity in the surface of the earth. As you can see, the extent area is also complicated landscape. The way to get surface water flow in civil engineering, the expert surveyor can do this, maybe by electrical engineering to visualization streamline using electromagnetic field. But in hydrology, based on grid-based digital equation models, is used to identify the direction of delegate in order to determine the path followed by water. The movement of the sediment and contaminant are ecosystem of the surface water flow prediction. So why we need to mediate the water? The first one is optimization uses of limited resources. And the second one is planning for safety and recovery from natural disaster. In this paper, it shows overall streamlined model process, and it can be divided into 3 phases. The first phase is begin with the data that import into the system as a digital image. And the phase 2 is interpolation models. It can be divided into two techniques. The first technique is deterministic technique, and the other geostatistics technique. And the last phase is streamline models. It's also divided into two types. The first type is based on vector form, and the other based on raster form. And finally, we got streamlines. What is digital equation models, or DEM? DEM is digital model or 3D dimensional representations of terrain surface created by equation data. This can take from synthetic aperture radar or SAR technology, use a radar system as can shown in the picture that you can imagine. And another technique we call airborne laser scanning with LiDAR is pick up with the plane or helicopter, something like that, and take data that we want and get it in 3D data images. The research problem is the individual model have a constant depending on such condition as a type of terrain. The second is difficult, therefore, to design the model that able to be universal use for all regions. The third problem is very approach adopt for use as interpolated techniques and various data types for streamlined model process are challenges. The objective is a review of the streamlined model process to describe interpolation technique, and finally they implemented at the model on the complicated terrain at Khao Luang Nature Park, Thailand. Okay, let me talk in detail. The first phase and second phase we call pre-processing phase. As I mentioned before, the first phase that took data from them and got from two main remote sensing technology, SAR and LiDAR. The output of them can be divided into three styles of 2 dimensions, as shown on the table 1. The pattern can be in square, triangular, and contour has its own property as shown on the table 1. We can show and see each of data of them as a LiDAR point, contour line, raster, and thin. This paper is based on contour line pattern and grid pattern. The second phase is interpolation model, and we will talk with the deterministic and next with the geostatistic technique. For deterministic technique, R use interpolate the solution of partial difference equation that can divided and it are to that traditional technique are the inverse distance weight technique and triangular regular network technique. For IDW technique, it will use at least 3 null point to interpolate unknown point. As you can see on the picture, we want to know equation of the unknown point that between 3 points have its own equation. As in example, on the top left, 12 and 10 for its equation, and we want to know at this point what is equation that can calculate by IDW technique. For thin technique is more structure that including with the triangle number, and each number can be interpolate the unknown point of its equation that can calculate by using triangular property. For instance, the polynomial function is used to interpolate the data over square area and to evaluation the slope of students. The last phase is streamline model. Okay, as you can see in the previous phase, for the DEM data, we got the known equation, some equation of data, and the second one in the second phase we try to interpolate that unknown point that we want to know its equation much as possible. Then the last one is we will try to draw the streamline by using based on vector form and another one based from flutter form. As you see, the equation data on the laser form as rectangular structure of pixels in digital images. The concept of the streamline is drawn to non-smooth part from starting pixel to adjacent pixel that are surround the starting pixel under specific criteria to represent the water flow. The egg algorithm is a good one to let this research pick this algorithm to compare the other. In this figure, it shows process of the egg algorithm and start with the center pixel, and they try to select or check the neighbor equation that the algorithm will find out the direction for egg angle. As you can see in the example on the figure on the right, A and B, compare with the original dim and flow direction. The arrow will show direction of the water that flow in that direction, because surround of the pixel, the water flow will select the lowest elevation and flow that direction. And another one is vector form data. The vector form data to find out and draw the streamline by using analytical techniques. Many of techniques that can use by vector in vector data form, such as separation of variable, eigenfunction. Similarly, Laplace transform of Fourier or green function has been used the particular solution of PDE, and it also can use for with the numerical technique also. When we compare and show the technique divided into two forms, differential form and integral form. This paper will select in integral form the battery element method to compare for the author with dx. In the battery element model, will give the solution which are semi-analytical. As you can see in the figure 4 and 5, is shown process of semi-analytic solution is quite easy to understand for this method. The first process is collecting data into memory and approximating the slope of equation by using boundary integral, and it's also prepared the information for flow direction determination. And when they got the data of the semi-analytical, the algorithm will determining the direction and create the streamline. As you can see on the figure 5, the flow direction model can be found by using vector data input, and they try to find out the direction by using gradient of the contour line by separate each contour line in the sub-segment and point and interpolate the evaluation on the area not in contour line, and to calculate the angle that the smallest equation, and as this means the water and flow this direction. The step as I mentioned before. Okay, we can summarize the equation data about for the raster form and vector form. The raster form that's construct from image processing technique. In contrast, vector form is construct based on the solution of PDE by using BEM, and they compare with the DX in raster form. The experiment result at Khao Luang Nation Park. This figure is shown them image and the oval circle is shown the real water of the streamline model. This figure is shown compared with the source them data with the based on the DX algorithm. As you can see, the streamline view that shown on the right figure generated by using the DX algorithm. And we compare with the based on BEM by using the contour line and vector form data. You see the BEM has created more detail of the waterfall when we compare with the DX, right? This figure is show all of the sources, them data, the algorithm, and BEM as a same water flow. The conclusion is the selective survey of computation images was presented. Agents has focused on this continuity of streamline by semi-analytical method compare with the algorithm. The result of semi-analytical were very much more detailed, delineated, ring over the hue regions, and more continuous streamline than those of the DX algorithm. For me, why I thinking and selected this paper to review, because actually BEM can draw the streamline small detail, but this algorithm is still use more resources and more computation time. So for my research, I try to find out the suitable parallel algorithm to solve that solve that problem, to make a better process in the use least resources and use least computation time by using parallel algorithm and multiple node processing, maybe on cloud service. Okay, thank you for your attention.